Welcome back, students. When both base and number of logarithm inequality are changing, that means they are polynomial functions, it is not that easy to handle. So here in this part, we will be learning a simple strategy to handle such complex problems. Let's begin. Logarithm inequalities can be made very complex when we have both base and number, which are some functions in x. So let's see how we can handle these kind of questions. So let's take the first question, wherein we have to solve the logarithm inequality, which is a multiplication of log to the base x, log to the base 2x and log 4x to the base 2, and its product is greater than 1. Okay. Now let's take this log. As I've told you, whenever we are dealing with log inequalities, we have to first talk about the basic conditions. So because here I am having number, here I am having 4x. So I can say that 4x has to be greater than 0. This implies x should be greater than 0. If I talk about the base x, 2x, both of them should be greater than 0 and x cannot be equal to 1 and 2x should be greater than 0. And 2x, this implies x greater than 0, and 2x cannot be equal to 1, this implies x cannot be equal to half. So we got three important things from here, that x should be greater than 0 and x value cannot be equal to 1 or half. Okay, so these are my basic conditions. Now let's try to solve it. Now you can see that here this is base x, base 2x, and here base is 2. Okay. So what I am going to do is I am going to make all of these bases same. So I can write log 4x to the base 2 as it is. Okay. Now because we know a property that log b to the base a into log a to the base b product is 1. So I can always write log b to the base a as 1 upon log a to the base b. Now the reason here is because here I can see 2, here I can see 2. So I will just change the same basis. So this becomes log x to the base 2 log 2x to the base 2 greater than 1. Okay. So let's see how we can solve this inequality. Okay, so let us write this inequality again. Log 4x to the base 2 upon log x to the base 2 log 2x to the base 2 greater than 1. Okay. Also we know that we have two important conditions, x greater than 0 and x not equal to 1 or half. Now to solve this equation, students, what we are going to do is, let us assume that log x to the base 2 is equal to y. If I will put this, so here it becomes log 4 to the base 2 plus log x to the base 2, that is y, upon here I have y, and this becomes log 2 to the base 2 plus y again greater than 1. So this finally gives me 2 plus y upon y into 1 plus y, putting 1 on the left hand side minus 1 greater than 0. So I can take this as LCM. So this becomes 2 plus y minus y square upon y into 1 plus y greater than 0. So here y gets cancelled. I can say that this is 2 minus y square y into 1 plus y greater than 0. Just I have to remember this thing, that y is log x to the base 2. Okay, so if I want to write the solution for this, critical points would be, zeros and poles would be 0, minus 1. Here it would be minus root 2 and here it would be root 2. If I take value which is greater than 2, root 2, so this would give me negative. Okay, so positive, negative, positive, negative. We want positive region, so this one and this one. So I can say that I got two solutions. Either my y lies between minus root 2 or minus 1, or also I have y lying between 0 and root 2. But what is y? Log x to the base 2. So I will rewrite this way, and here again log x to the base 2. Okay. So now I can get the complete solution for x. This would be 2 raised to the power minus root 2, and this will be 2 raised to the power minus 1. Okay. And here it will be 2 raised to the power 0, which is 1, and 2 raised to the power root. But I have to keep in mind x has to be greater than 0. Yeah. X is not equal to 1, neither half. Yes. So yes, this is my complete solution. Okay. So let's move to the next question. Okay, so here you can see that both base and these are functions in x, right? This base is also a function in x, and this is also function in x. Okay, so let's see how we can handle it. I am not aware that this base is greater than 1 or it is lying between 0 and 1. So I have to make always two cases. Okay, this is the first thing that you have to understand. Before that, let us write down the basic conditions. That 2x upon 5 should always be greater than 0. This implies x should always be greater than 0. The second basic condition. Now for this logarithm function, this will be my number n. So this also should be greater than 0. So log 2x upon 5 base 2 should be greater than 0. So 2x upon 5 should be greater than 2 raised to the power 0, which is 1, or x should be greater than 5 by 2. These are my basic conditions. Okay, some more basic conditions about the base. Now this base should also be greater than 0. So I may say that x square minus 12x plus 30 upon 10 should be greater than 0. Okay, so I'll have x square minus 12x plus 30. This should be greater than 0. Okay, let's keep it as it is. We always remember that it will be greater than 0. Let's try to analyze the two cases. When I will have x square minus 12x plus 30 upon 10, there will be two cases, right? It can be between 0 and 1. Okay, and it is also possible that this whole base is greater than 1, right? Okay, now let's understand this. If I say x square minus 12x plus 30 upon 10 is lying between 0 and 1, right? So that means what will happen to sign of inequality? That will be changed. So I will have log 2x upon 5 to the base 2. Sign of inequality will get reversed, so less than equal to this whole quantity raised to the power 0. So that becomes less than equal to 1. Right? So this becomes less than equal to 1. Okay, I'll talk about the next case. When I say this quantity is greater than 1, sign of inequality will not change. So log 2x upon 5 to the base 2 will be simply greater than equal to 1. Okay, so basically what I have to do is I have to get the under this stream, when this is true, I have to take the intersection of these two with the basic conditions intersection, and then finally their union. Union of these two will be my final answer. Okay, so let's see what we will get when we will solve these two conditions. Okay. So on one side I have x square minus 12x plus 30 upon 10 is lying between 0 and 1. Okay, and on other side I have x square minus 12x plus 30 upon 10 is greater than 1. Okay, so we got that in this case I will have log 2x upon 5 to the base 2. That will be, because sign of inequality will change, so less than equal to 1. And here log 2x upon 5 to the base 2 will be greater than equal to 1. Or this can be solved as this is very simple to solve. This implies 2x upon 5 less than equal to 2 raised to the power 1, 2. So I can say that x is less than equal to 5 in this case. and here I will say that x is greater than equal to 5. But then I have to solve the first inequality also in both the cases. Okay, let's see what first inequality gives. It gives me x square minus 12x plus 30 should be greater than 0, and also x square minus 12x plus 30 less than 10, so that become plus 20 less than 0. Okay, I have these two conditions. So this gave me x minus 10, x minus 2 less than 0. Okay, because it is lying between 0 and 1. So here I have, let's solve this condition. So this becomes 2 and 10 as 0. So it will be lying between 2 and 10. Okay. Now x square minus 12x plus 30 greater than 0. So if we'll try to split this, let's check out its discriminant. B square 144 minus 4ac 120. So that becomes 24. Okay. So I will have its root as 12 plus minus root 24 upon 2. It will be greater than 0. Okay. But we also had one more solutions that x should be less than 5 from here, right? And if you remember, two more solution that x should be greater than 5 by 2. This is something that we always have to remember, because x greater than 0, x greater than 5 by 2, this both of them gave me one solution that x should be greater than 5 by 2. Okay. So what I'll do is x greater than 5 by 2. So the intersection gives me the final solution that it would be 2 because it is 5 by 2. Okay. And less than equal to 5 also. Okay. So I have solution as 5 by 2 to 5. This gives me solution from here. Okay. Let's talk about the second case. When you have x greater than equal to 5 from here. Okay, you have equality sign in 5, so I can put an equality sign with 5 also. Okay. Now, when I solve this first equation, it comes out to be x square minus 12x plus 20 greater than 0. So I have solutions like this, greater than 10 and greater than 2. Okay, but one solution was that it is always greater than equal to 5, like this. Okay, and x less than 2, x is greater than 10, and x should be greater than 5. So the complete intersection would be x should be greater than 10. So I got basically two solutions, x greater than 10 and x belongs to 5 by 2 to 5. So this is not a very complex problem. The thing is, if you start handling it in a proper way, okay, what is step number 1? Always talk about the basic conditions. Okay, talking about base, talking about the number n. After that, if base is also function in x, then you have to take two streams, right? If it is between 0 and 1, and if it is greater than 1. If it is in between 0 and 1, change the sign of inequality. And if it is greater than 1, just make the sign of inequality same and keep on solving the equations. Okay, so let's solve one more problem in which we have again base, which is not simple base, but yes, we have to take the cases. So you can see that here we have 2x plus 3. Okay, but before I solve this condition in equality, I will take some basic conditions. Okay, so what will be my basic conditions? I'll talk about the number. So because your x square is always positive, I don't have to talk about this. 2x plus 3 should be greater than 0, and 2x plus 3 not equal to 1, because base cannot be 1. So I got x should be greater than minus 3 by 2 always, and x should not be equal to minus 2 upon 2 minus 1. So these are my basic conditions. Okay. Now because right now I am not aware whether my base is between 0 or 1 or greater than 1. So again I will take two cases. Okay. In one case I will say that 2x plus 3 is lying between 0 and 1. In another I will say that 2x plus 3 is greater than 1. What it means? Here it means that 2x will lie between minus 3 and minus 2. So x would lie between minus 3 by 2 and minus 1. Okay, and here it would mean x will be greater than minus 1. Okay. Now when I say x is lying between, this sign of inequality will change. So I'll say that x square, when I'm cancelling this, I cannot cancel log 2x plus 3 as it is, right? I will cancel only after understanding the base. So x square, I'll change the sign of inequality greater than 2x plus 3. Okay, and here x square would remain less than 2x plus 3. So I have to solve these in under two streams. So x square greater than 2x plus 3, this will give you an quadratic equation x square minus 2x minus 3 greater than 0. Okay, so this will give you x minus 3, x plus 1 greater than 0. So if I'll plot it over here. If I will plot it, it would be like this, minus 1 here, 3 here. Okay, it is greater than 0, so this region and this region. But I already said that x is lying between minus 3 by 2 and minus 1. So minus 3 by 2 will be here between this and this. So this will give me an overlapping region only this much. So I got this solution that x is lying between, from this I got the solution that x is lying between minus 3 by 2 to minus 1. Let's take the next case. Here I will have x minus 3 into x plus 1 greater than 0. On the same number line less than 0, I'll have minus 1 to 3 in between them, but x should always be greater than minus 1, no problem. So I got this intersection between minus 1 to 3. So minus 1 to 3. But you just have to remember the two basic condition. Is your x greater than minus 3 by 2? Always this condition, okay. And the next condition, that x should not be equal to minus 1. You cannot put rectangular bracket in front of minus 1. That is not possible. This is something that you have to remember. So these two conditions are following it, so we don't have to worry about it. Okay. So this was all in logarithm inequality complex problems. Students, I hope now you got an idea how to start a problem and how to get to the final answer. What kind of questions were asked in previous engineering exams? For this, stay in tune with me for the next part. Have a nice day. Thank you.